In this video, we will see next question in our LeetCode 75 list, and we started binary tree, and let's see what the question is. Let's go to the screen first, and yeah, here the question is count good nodes in binary tree. And what does mean good nodes? Let's see the question. Given a binary tree root, a node x in the tree is named good if in the path from root to x there is no node with value greater than x. Okay, it means we have a node and we have a path from root to that node, and we have values from root to that node, the nodes which we visit from root to that node, the path basically, the nodes which are there in the path from root to that node, and that's the value of those nodes shouldn't be greater than the nodes which we are at present now. Then that node can be called as good node. Basically, that node's value should be greater than all values which we have visited from root to that node. The path, basically the path which we followed from root to that node, in that path we shouldn't visit value which is greater than that node. Then that node can be called as good node. Okay, it's basically good node means this. So let's see first example. Here we have this example, that is this 314, 313, 315. Let's go to the root node. For the root node, the value from root node to the root node, like the path from root node to the root node will be same, right? Because that's the three, that is root node always will be counted. That's what I mean. And you also understood that why we will count root node always, because it is the greatest node in that path. Then go to the next level, that is 1 and 4, in which we see that 1, for the 1 we go from 3 1, then we already visited 3 which is greater than 1, so 1 we can't count 1 as a good node, but that is 1 isn't good node. So yeah, then we have 4. From 3 to 4 we can see that 4 is the greater from in that path, so we'll count 4. Then we go to the 3. For the 3 we the path is 3 1 3, and here we have, that is 3 is the greater value, right? We visited 3 but it is the greater value, we don't have 4 in that path, so we'll count this node also. Then we have 1. For this one we have path 3 4 1, and we already visited both nodes which are greater than 1, so we should not count 1 because it is not a good node. 1 isn't a good node. Then we have 5, and the path is 3 4 5, and yeah, this is the good node because it is greater than 4, it is greater than 3. So yeah, how we will solve it? So there is one traversal in binary tree which is preorder traversal. In preorder traversal, what we do, if you know the preorder traversal concept, then this question is easy. And let's see what preorder traversal means here first. Preorder traversal is basically means you need to visit first root, then you will go to the left, then you will go to the right. Okay, so basically whichever you go, you need to visit first, like whichever, not the whichever means I didn't mean the whichever. You need to visit first root, then you have to go to the next, to the next left, then you need to visit that node, then you need to visit the next left, or there is no left, then go to the right, and if you completed the right, then back traverse. It basically means that. So the rule for preorder is visit the node, take the value, and go to the next node which is at left, or which is at right. So we can consider the roots value here. That's the basic idea. So let's see how we can use this preorder traversal in to solve this question. So for this example, we'll go to the root, and we took the 3, and now we want to count from left and we want to count from right. That summation we will return as an answer, right? So here what we will check, we want a max value, we will need a max value in that path. that I have visited first before coming to that node. So for that we need to maintain one variable, right? So we will maintain one variable which will store a max value towards that to that node in that path, and then we will check the root that node's value, is it greater than or equal to the max value which are visited in that part. If it is yes, then we'll increase the count. If it is not, we will not increase the count, and then we'll go to the left and we will go to the right, and we will return the summation of the count and the left count and right count. Okay, that's the whole idea, and let's code it. I'll guarantee you will definitely understand this in my code. Okay, let's see what. Let's code it. So what I said ki we need to maintain one max value which we have visited. So max value right now I am visited is, let's say value can be negative. So let's say ki I have max value int min, and I'll return a pre-order traversal as, or we can say count good node, count good nodes from this root, and till then I have visited just this max value. Okay, and let's write this function. This is re node, and we'll take this, and max value basically it will be int, and yeah, we'll see if my root equals to null, then we'll return 0. Obviously we don't have anything, we'll return 0, and we'll take a count which is 0, and if my root value is greater than or equal to max value. Why I'm saying greater than or equal to? Because here in example number 1 we have saw that we counted this 3, though the root value was 3. It means the node's value should be greater than or equal to max value which we have visited in that path. If it is greater than or equal to, then we'll increase the count. We'll go towards the left one, that is to count the left part, that is the left count, and let me take this, and for this we are, as we are going to the left, so go to the left, root and left, and max value, what will be the max value? It will be the max of max value and my root value. Okay, and the same thing for the right. We'll go to the right and we'll take the right count, and it will be okay, this is only, and we will return total, that's count plus left count plus right count, and yeah, just let's run it and let's submit it. So it is accepted, and we can see that we have solved this question. And how much time complexity is taking is, as we are visiting to every node for just for once, so it is taking big of n time. And for the space complexity, this is the time complexity, and for space complexity, as we are visiting, like we though we are not storing it in the stack, that it is a recursion, so internally it is using stack, and it will store uh, space of total height that binary tree has. So space complexity will be big of h, that is the total height that we are visiting. And yeah, that's it for guys. So yeah, bye bye.